The moon was born in violence, not slowly, not peacefully, and not alongside Earth as some quiet companion in the early solar system. It was born from one of the most catastrophic collisions in planetary history. More than 4.5 billion years ago, long before oceans, forests, dinosaurs, or humans, Earth was still a half-formed world, hotter, more unstable, and far more dangerous than the planet we know today. And then something enormous hit it. A lost world, a planet-sized body, a collision so extreme that it may have melted much of Earth, thrown vast amounts of rock into space, and created the moon from the wreckage. This is the leading scientific explanation for how the moon was born. And if it is true, then every time you look up at the moon, you are looking at the remains of a planetary disaster. A disaster that may have made life on Earth possible. To understand how this happened, we have to go back to the beginning. About 4.6 billion years ago, the solar system was forming from a cloud of gas and dust. The sun ignited at the center. Around it, countless fragments of rock and metal began colliding, sticking together, and growing. Some of those fragments became planets. But the early solar system was not orderly. It was chaotic, violent, unfinished. Young planets were still being built through constant impacts. Worlds collided with worlds. Some merged, some shattered, some disappeared completely. Early Earth was one of those growing worlds. It was not yet the blue planet we know today. There were no stable continents, no living oceans, no breathable atmosphere. Its surface may have been dominated by magma, fresh impacts, and internal heat. And somewhere nearby, another planetary body was forming. Scientists call it Theia. Theia may have been about the size of Mars, not a small asteroid, not a moon-sized object, a world. And at some point, Theia and Earth ended up on intersecting paths. What happened next may have changed everything. The impact was so powerful that normal human language almost fails to describe it. This was not an explosion in the sky, not a crater in the ground, not even a global disaster in the modern sense. This was an event that reshaped the planet itself. When Theia struck the young Earth, the energy released was enough to melt rock, vaporize enormous amounts of material, and blast debris far into space. Some of Earth's outer layers were torn away. Some of Theia was destroyed completely. Some of both worlds mixed together in an expanding cloud of superheated debris. And from that debris, the moon began to form. That sounds like science fiction, but the reason scientists take this idea seriously is simple. The evidence points to it. The biggest clues came from lunar rocks. When Apollo astronauts brought samples back from the moon, scientists began comparing them to rocks from Earth. What they found was extraordinary. The moon and Earth were deeply connected. Many lunar rocks had chemical and isotopic signatures strikingly similar to Earth's mantle. In particular, oxygen isotopes matched so closely that it suggested the moon was not some unrelated object captured from elsewhere in the solar system. It seemed tied to Earth's origin. But the moon also had strange differences. It contained much less iron than Earth. It was depleted in many volatile elements, substances that tend to evaporate easily under intense heat. and evidence suggested the early moon had once been covered by a global ocean of molten rock. That combination was difficult to explain with older theories. At one time, scientists considered whether the moon had simply formed somewhere else and later been captured by Earth's gravity. But that idea struggled to explain why the moon looks so chemically similar to Earth. Another idea suggested Earth and moon formed side by side from the same region of material. But that did not fully explain the moon's unusual composition or the dynamics of the Earth-Moon system. A third theory proposed that the moon had spun off from a rapidly rotating young Earth. Interesting idea, but again the evidence did not fit well enough. The giant impact hypothesis explained more of the puzzle than any rival theory. That is why it became the leading model. In its most familiar version, Theia struck Earth at an angle, not directly head-on, but obliquely, the kind of collision that can rip material outward instead of simply crushing both bodies together. In a matter of hours, maybe less, both worlds were transformed. Earth was partially melted, Theia was largely destroyed, and a huge disk of molten and vaporized rock formed around the planet. For a long time, scientists thought the moon slowly formed from this debris disk over months or years as orbiting material gradually clumped together. But newer simulations have suggested something even more dramatic. In some models, a moon-like body could have formed extremely quickly, perhaps within hours, as material was launched into orbit and rapidly assembled. That doesn't mean the case is closed. Scientists still debate the exact details, but the core picture remains the same. A giant impact, a ring of debris, a newborn moon emerging from destruction. And that newborn moon would have looked nothing like the one we see today. It would not have been cool, gray, and silent. It would have been hellish. The early moon was almost certainly molten. Its surface may have been a global magma ocean, hundreds of kilometers deep. Imagine an entire world covered in glowing liquid rock. Over time, that magma ocean began to cool. As it cooled, minerals separated by density. Lighter minerals floated upward and began forming the moon's first crust. One of the most important of these minerals became anorthosite, the pale rock that still makes up much of the lunar highlands. So when we look at the bright highlands of the moon today, we may be looking at the frozen remains of that ancient magma ocean. This matters for one big reason. The moon preserves history that Earth has lost. Earth is geologically active. Its crust is constantly recycled by plate tectonics. Weather, oceans, volcanoes, and erosion erase ancient evidence. The moon is different.
It has no rain, no rivers, no active plate tectonics, no global erosion like Earth. It preserves ancient scars, which means the moon is not just a beautiful object in the sky. It is a record of the earliest solar system, a kind of fossil world. That is why scientists treat it almost like a crime scene from deep time. Every rock sample is evidence. Every crater is a timestamp. Every isotope ratio is a clue. And yet, even with all that evidence, one major mystery remains. If the moon formed partly from Theia, then why is it so similar to Earth? That question has driven years of debate. You might expect the moon to carry a clearly different chemical identity if a large part of it came from another world. But in many measurements, Earth and moon look almost like twins. So how is that possible? One possibility is that the impact was so violent that Earth and Theia mixed thoroughly, blending their material together before the Moon formed. Another possibility is that Theia itself was made of material already very similar to Earth's. And recent research has supported that second idea more strongly than before. Some studies suggest Theia may have formed in the inner solar system, not far from Earth. If that is true, then Earth and Theia may have started with similar ingredients. That would help explain why the Moon's isotopic fingerprints are so close to Earth's. But scientists are still testing how well that explanation fits the full picture, because not every detail is solved. Some studies detect subtle differences between Earth and Moon. Others emphasize their near identity. Some impact models match the chemistry better. Others better explain the orbit and angular momentum of the Earth-Moon system. So while the giant impact model is the leading theory, the exact version of the event is still being refined. That uncertainty is not weakness. That is how science works. The broad story becomes stronger as the details are challenged. And one of the strongest clues of all is timing. The Moon formed very early. Evidence from lunar rocks suggests it likely formed within roughly the first 60 to 110 million years of solar system history. Some of the oldest lunar zircons date back around 4.46 billion years. That means the Moon has been with Earth almost from the beginning, not as a late addition, but as part of Earth's earliest story. And its effects on Earth may have been profound. Right after its formation, the Moon orbited much closer than it does now. It would have looked enormous in the sky, far bigger than today's full moon. Over billions of years, tidal interactions transferred energy from Earth's rotation to the Moon's orbit, pushing the Moon farther away. Even today, it is still drifting outward by about 3.8 centimeters per year. That may sound small, but over geological time, it changes everything. The Moon helped stabilize Earth's axial tilt, reducing the kind of wild variations that could have caused extreme climate instability over long periods. It also raised tides, much stronger tides in Earth's early history when the Moon was closer. And while life on Earth depended on many different conditions, the Moon became part of the environmental framework that shaped the planet's long-term evolution. Without the Moon, Earth might still exist, but it might be a very different Earth. A different climate history, a different rotational history, a different planetary rhythm, possibly a different path for life. That is why this story is so powerful. The Moon is not just something that happens to orbit Earth. It may be the product of the very event that helped define what Earth would become. A companion born from destruction. A second world made from the wreckage of two others. And there's something almost unsettling about that, because the Moon feels permanent, ancient, calm, almost gentle, but its origin may have been unimaginably violent. Everything about it begins with impact. A planetary body appears. A young Earth is struck. Rock turns to vapor. A debris ring forms in orbit. A molten world rises from the wreckage. And then the sky changes forever. But there's one more reason this story matters. It reminds us that planets are not shaped only by slow and gradual processes. Sometimes history turns on a single event, a single collision, a single day,
a single catastrophe that rewrites the future. Without Theia, there may be no moon as we know it. Without the moon, Earth may have evolved differently. And without that different Earth, we might not be here asking where the moon came from at all. So when you look up at the moon tonight, you are not just looking at a distant object reflecting sunlight. You may be looking at the remains of Earth's worst day. A world built from molten debris, a survivor of planetary violence, a fossil from the birth of our planet. The moon was not captured. It was not quietly assembled beside Earth. It was born from catastrophe, born from fire, born when two worlds collided and became one story.